In this video or today, we are going to study about the observable canonical form, that is the OCF. In the previous two lectures, we have tried to cover what do you understand by the canonical form. Okay, how the state model, different types of the state model canonical form can be derived using the transfer function. In order to that, we have discussed the four different types of the canonical form. First was the controllable canonical form. Second was the observable canonical form. Third was the diagonal canonical form, and fourth was the Jordan canonical form. Right? Diagonal and Jordan canonical form are almost same. We will see how they both are the same. After that, we have covered the controllable canonical form. In the canonical form, we have seen the last row of the input matrix, that is the A matrix, is represented by the coefficient of the transfer, you can say the characteristic equation. Okay, let's say the 1 upon sq plus a2s square plus a1s plus a naught is there in the denominator in the characteristic equation. Then you have seen the matrix whatever is met, that is 0 1 0 0 0 1, and it is the coefficient a naught minus a1 minus a2, like that. This is the A matrix. Okay, and you also have seen the B matrix was prepared with the help of like this 0 0 1, okay, and RT. Okay, so these are the case. These we have discussed in the controllable canonical form. Okay, today we are going to discuss the OCF, observable canonical form. Let's say we have the transfer function of the third order VIS upon RS, that equals to B2s square plus B1s plus B naught divided by s cube plus a2s square plus a1s plus a naught. So this is a third order system. Yes or no?
Yes, sir.
Third order system. Right. So this equation may be written as like this: s cube plus a2s square plus a1s plus a naught into ys, right? Ys equals to b2s square, sorry, yes, please tell me, b2 s square
S
plus b1s
B1S
plus b naught
plus B naught.
equal into
into
rs,
RS.
right? So when can you write this s? What is this s represent? S representing the
Derivative.
Laplace operator. SQ represent, you can say, the differential form of y. Yes or no? Can we write dq into ys or dqy instead of the s? A2
Yes,
d square plus a1 d plus a naught into y. Can we write like this? Yt.
yes, writing.
Yes, sir.
Okay, equal to, you can write b2 d square plus b1 d plus b naught into rt. Yes or no?
Yes, sir.
So dqy is equals to take the common term of the d square, d, and simple constant. Okay, so it will be the d square b2r minus a2y. Is it right? b2r minus a2y, if you take
Yes, sir.
this side, right? In similar way, when you take the d term, then we will write b1r minus, please tell me, a1y,
Y.
and in the last you can write b0r minus
Minus A.
of a0y.
Writing.
Okay, okay, now y equal to becomes this dq, take this side, so it becomes d minus 1 b2r minus of a2y plus d to the power minus 2 b1r minus a1y plus d to the power minus 3 b naught r minus a naught y. Okay. Now let assume or choose the variable, state variable. Choose the three variables or state variables. Okay. Be x1 is equals to y, x2 and x3. Okay. Let's say this is the x1. So x1 becomes, please tell me, x1 becomes d inverse b2r minus a2x1 plus d per points 2 b1r minus a1x1 plus d to the power minus 3 b naught r minus a naught x1. Okay, is it okay? Okay, so yes or no?
Yes, sir.
Okay.
Yes, sir.
Now what is the x1 dot? Please tell me. This is the 1 by d. This is the 1 by d by dt. Okay, this is the d inverse means this one. Yes or no? So
Yes, sir.
x1 dot means d by dt. It will cancel. Yes or no?
Yes, sir.
It will cancel. So it becomes b2 r minus a2x1 plus क्या होगा?
D
Please
inverse.
tell me.
D inverse.
D inverse. Very good. D inverse b1r minus
B1R minus
a1x1
A1X
plus d to the power minus 2
minus 2.
b naught r minus a naught x1.
You know.
Right. Let's say this term is, let's say this term we have known as x2. Defining x2, let's say x2 is equals to d inverse b1r minus of a1x1 plus d to the power minus 2 b naught r minus a naught x1. Okay, so it means your x1 dot becomes b2r minus a2x1 plus, please tell me, plus
X2.
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 Very good. x2. Now tell me what is the x2 dot? What will be the x2 dot?
B1 or
x2 dot.
B1 minus B1 X2.
x2, yes,
So
this is
D inverse
x2.
B naught
This
R
is the
minus
x2.
B naught X2.
This is the
B1 R
x2.
minus A1 X1 plus D inverse
b1r minus a1x1
A1X1.
D.
plus d
D
inverse
B inverse.
B naught
b
R
naught r
B
minus
naught
a naught x1.
A
Right?
naught X2.
All now it is time to consider this one is the, please tell me, x3.
X3.
Okay, so x3 is equals to d inverse b naught r minus a naught x1. So x3 dot, please tell me,
B
b
naught
naught
R
r
minus
minus
A
a
naught
naught
X2.
x1.
X1.
Okay, now it means you have written three terms. First one is this one. Second one, if I'm not wrong, then you have written, okay, x2 dot is equals to b1r minus a1 x1, right, plus x3. This is the 2. And third equation is simple. That is the third. On the basis of this one, you can now represent the status space equation. x1 dot, x2 dot, x3 dot. Please tell me, x1 dot, x2 dot, x3 dot equal to, please tell me, क्या बनेगा? What is the matrix?
So minus A2
Minus
Minus
A2.
of A2, right? Minus of A2, then
plus
1.
1
plus
plus
1,
1.
then
0.
0,
0.
right? And it will the x1, x2, x3, and plus, please tell me,
B2 B2
r, yes,
R.
this is the b2.
B2.
Very good, very good. Okay. Now what is the x2 dot? Please tell me x2 dot is equals to
minus a
minus
A1.
of a1, then
zero
minus
Zero,
0, right? Because
zero
there is no x2 term.
1.
x2 term is 0.
one
Okay, and
one
then x3
1.
term is
one
1.
One.
Okay, and what about this one? So b1,
B1.
b1
b1 is there,
B1.
right? And what about the x3 dot? x3 dot is equals to minus of a naught,
minus a
A0.
naught
0,
0
zero
0
0,
0
and then it
b
is
naught
the
B
b
naught.
naught.
B naught.
So you can represent. So what the difference? What we absorbed? What the difference between the OCF
सर
and CCF?
सर उसमें रो थी
Yes,
लास्ट रो
very
में
good,
फर्स्ट
VCF.
very
कॉलम
good, very good. ये जो line देख रहे होगे आप, this one is now in the vertical, or you can say in the
Column.
column,
Column.
right?
column
ठीक है? Good. So what is now? What is last equation? You can write here. What is the y? Y is equals to x1. पहले डिफाइन किया है, चेक करो. Y equal to x1 and x2 x3 मैंने
Yes.
डिफाइन किया था, yes or no? So y equal to x1 1 0 0 into x1 x2
X1, X2,
x3. So this is the
x
equation. Now it is time to just draw the SFG with the help of this equation. Draw the SFG with the help of this equation, right? So let's say we are trying to make it clear. So how many state variables are there?
3
3.
3.
Y, यहाँ से हम YS ले रहे हैं, right? Let's say we have defined the term x1, then
X2.
x2, and what is x2?
X2 is equal to
x1 dot
x2 is equals to x1
X1.
dot,
x1 dot
X1.
x1 dot
right? Okay, and
X3.
then let's say we have the x3,
x3
or what is x3? x3 is equals to x2 dot,
x2 dot
X2 dot.
right? And then in last
X,
we
x3
have
dot
the
X3 dot.
x3 dot
x3 dot. ठीक है, x3 dot. Okay, and this one is your RT.
rt
Okay, अब हम equation पे आते हैं. Your first equation, Baj. Your first equation, based on the equation, you can write the equation only, right? So x1 dot is equals to, क्या है? x1 dot is equals to x2 plus b2r minus of b2r minus of a2x1 minus of a2x1. x1 से कितना आ रहा है? 8 minus 8.
Minus 8.
Yes or no?
minus ap
Yes.
Yes, sir.
Okay. So पहले तो हम इसको ये देखें. x1 dot से x1 कब मिलेगा? When you integrate. Yes or no?
Yes, sir.
x2 dot से x2 कब मिलेगा? When you integrate. And x3 dot से x3 कब मिलेगा? When you integrate. Yes or no? यानी it means you require 3 integrator. Is it clear?
Yes, sir.
Now come to the
Yes.
next. That is the x1 dot is equals to x1 dot is equals to, you have written. Please tell me x1 dot is equals to, और x1 क्या था बताओ?
So B2R minus
x1 dot is equals to b2r minus a2x1 plus
A2X
x2, है
plus
ना?
X2.
इसको मैं थोड़ा सा स्क्रीन छोटा कर देता हूँ जिससे हमें दिखाई देता रहे. Okay, it is clear. So x1 dot is equals to यहाँ से आएगा माइनस ऑफ a2, राइट? सो इसको हम लोग क्या इस तरीके से लिख सकते हैं? माइनस ऑफ a2. प्लीज टेल मी यस और नो?
yes sir
माइनस ऑफ a2 x1 प्लस b2r मीन्स यहां से इस पोजीशन पर एक r से आ रहा है, दैट इज योर, प्लीज टेल मी व्हाट इज द गेन? दैट इज द b2r and plus x2. So plus x2 is simple, you can take from this side plus x2. Yes or no? Is it clear?
Yes, sir.
Okay, so this is the case. Now next one is the x2 dot. X2 dot is equals to, please tell me, x2 dot is equals to b1r. So x2 dot is equals to, यहां से आपका क्या आ जाएगा बेटा? b1r, right? So you can write here b1r, then minus of a1 x1
A1 x1
minus of a1 x1, right, and then x3 तो आ ही रहा है, ठीक है, ओके. नाउ लास्ट वन इज द x3 dot. x3 dot is equals to b naught r. x3 dot is equals to b naught r. तो हम लोग यहाँ पे क्या लिख दें, प्लीज टेल मी, b naught r. b naught हो गया, then minus a naught x1, then minus a naught
x1
x1. So this one is the minus a naught x1.
minus.
ये बन गया आपका. Yes or no? Any problem? Any problem? So this is the signal flow graph of the derived picture. So this is simple OCF. Now just I am taking one example so that you can more understand with the help of one example. Just I am taking, let's say we have the example of ys upon rs is equals to 5s square plus 14s plus 8 divided by sq plus 9s square plus 23s, okay, plus 50. The question is convert or represent the transfer function in the OCF, okay, observable canonical form. So what you will do, your problem will start with the x cube plus 9s square plus 23s plus 15, okay, into ys is equals to 5s square plus 14s plus 8, right, into rs, right, and then you can write here y triple dot plus 9y double dot plus 23y dot plus 15y equal to 5 r double dot plus 14 r dot plus 8 r, okay. So you can simply write d3y my plus 9d square y plus 25dy plus 15y equal to 5d square r
23
plus 40dr plus 8r, right. So y equal to becomes, please tell me,
23 था
y कितना बन जाएगा बेटा,
सर 23 होगा 25 की
सर
जगह
23 डिवाइड
23 डिवाइड 25, अच्छा सॉरी,
25 dy की please.
ओके 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 23 थैंक यू. सो y, हाँ, y इज इक्वल टू कितना बनेगा, d टू द पावर माइनस 3 को इधर ले भी जाना है, ठीक है, माइनस भी करना है, तो इट बिकम्स, प्लीज टेल मी, एनीवन टेल मी डायरेक्ट आंसर, d इनवर्स है ना 5r माइनस ऑफ 9y, ठीक है, ओके.
यस सर
देन d टू द पावर माइनस 2, ठीक है, d टू
Minus
द पावर माइनस 2
14
क्या बन
R.
जाएगा, 14r
14
माइनस
r
ऑफ
minus 23y
minus 23.
23y, यस, हाँ,
यस सर
23y, right, and then आगे बताओ, d to the power minus 3
minus 3
into
8r minus
8r
15y
minus 15,
15y
ठीक है. हमने डिफाइन कर दिया x1 इज इक्वल टू y एंड x2 x3 आपने अलग अलग से दे दिया, x3 बी द 3 state variables, right. So what will be your equation now, y is equals to x1, right, x1 is equals to d inverse 5r minus of 9 x1 plus d to the power minus 2 14r minus 23 x1 plus d power minus 3 8r minus of 15 x1, right. Now what is x1 dot, x1 dot क्या हो गया, please tell me, 5r minus
5r minus
9x1
9x
9x1
plus d to the
plus
power
d inverse
minus
minus
1 है ना
14r
14r minus
23x1
23x1 plus d to the
plus
power
d to
minus
the
2
power minus 2
8r minus 15x1. अब क्या करेंगे, what is the next step, please tell me,
x2
x2.
sir x2 is
तो x2 क्या हो गया बेटा, what
d
is the
inverse
x2,
d inverse 14r
okay,
plus
yes. So x2 को हमने डिफाइन कर दिया, x2 is equals to d inverse 14r minus 23x1 plus d to the power minus 2 8r minus 15x1. ठीक है? Then what is x2 dot? x2 dot is equals to
14r minus
okay.
23.
First of all,
14r minus
wait
23x.
a minute. x1 dot. x1 dot is equals to finally you can write 5r minus 9x1 plus
Plus
x2.
x2.
Okay, or you can write this equation as a then
x2 bar. x2 dot.
x2 dot. x2 dot becomes, please tell me, 14
14r
r
minus
minus
23x.
14r
23x1
minus
and then
Plus d inverse
plus d
18.
inverse 8r minus
8r minus
15x1. Okay, and now it is the x3 sorry x3 is equals to d inverse
D inverse
18r minus
8r
15x1 and then you can write x2 dot. x2 dot is equals to
x3.
14r minus
Sir
23
8r.
x1
Sir
sorry
x3. Sir
okay
x3 8r minus.
okay plus हो गया x3 right and then your last term is your x3 dot. Okay, x3 dot becomes, this is the b and x3 dot is equals to 8r minus 15
minus 15.
x1 right 15x1. So now based on this you can write the x1 dot x2 dot. Please tell me what will be the equation. x1 dot x2
So
dot
minus
x3 dot
910
minus 9
9 1
1 0
0
and
minus
here
2301
minus
23
23
Minus 23.
0
0
0
1
and
1.
1.
1
Very good.
1
And then
minus
Minus
15
15.
minus 15 0 0. Very good.
0.
Very nice. x1 x2
x2
x3
x3.
and then
514 8
514.
514 yes 514
Yes.
8 r. ये हो गया आपका. Very good. And y equal to x1. So there is no need. Simply you can write 1 0 0 and yes x1 x2 and
x2
x3. So this is your state space representation of OCF and you can draw the, I hope you can draw the signal flow graph with the help of this picture also. Is it clear? Any doubt?